In the lesson on subqueries and CTEs, common table expressions, I promised I would show you a recursive CTE, but I wanted to hold off until I could show you how to do the same thing with the UDF at the same time. And now we're at that spot, so I'm going to keep my promise and show it to you. The family database has an excellent hierarchy, and just to review that very quickly, we'll select all from person. So here's, for example, James Holloway. He's person ID 2. And then here's James Holloway, his son. And person ID 2 is his father. So James is the father of James. And James's mother is Kelly. And this is called the adjacency pairs pattern of modeling a hierarchy, because within the row you can think of the person and then the parent row both being represented adjacent to one another as a pair right there in the table. So with that understanding and refresher of the family database, what we want to do is go ahead and select out the entire family tree and navigate this hierarchy and return back multiple generations. An application programmer might want to navigate this node by node by saying, and I'll walk through a quick example. Here's person 1, Kelly. Let's find everybody who is under Kelly. Here's James. James is 5. Let's find everybody under that person, and sort of walk through this entire tree of navigating every node. Navigate down, navigate up, and just walk through node by node. But if you have a hierarchy, say you have 1,000,000 parts in a bill of materials part, and this hierarchy has 1,000,000 wide, but is maybe only 4 levels deep. It'll take 1,000,000 hits to navigate it, navigating it up and down using a recursive procedure, iteratively walking through every node. So we don't want to do that. We don't want 1,000,000 hits in the database. What this method will do is find everybody one generation at a time. So in that 1,000,000 node example, if it's 4 levels deep, we'll only find that we need to hit the database 5 times, one for each generation, and then once at the end to say no more found. And that's how this function works. We start with a simple person ID, which is where we're going to begin building this tree. This is a multi-statement, table-valued function. It's going to return a tree. This is a table variable defined with person ID, last name, first name, and then what level, which is an integer, we are at, or which generation they're at. We're going to populate the tree by doing some loops. So the first population of the tree is the top level, also called the anchor level of the hierarchy. And for this level, all we need to do is select the person ID, last name, first name, and the level, which we've already set as 1, from person ID, where person ID equals our variable person ID, and that's our input parameter. So all this does is find the first person and pre-populate the tree with this first person. Then, using the while and at row count, we'll continue to loop. Now at row count will always have the number of rows returned or affected by the previous SQL statement. So if we found somebody, that should be equal to 1 right now. So as long as at row count is greater than 0, meaning as long as we find somebody, we're going to continue to insert into the tree, and what this select does is it finds the next level. It finds the next level by joining the person table basically to the tree and finding where the next level has a mother or father, which is found in the current generation of the tree we're looking through. So to put this in other words, the first pass we find one person up here in the anchor. The next pass we find everybody where the anchor is their father or their mother. And we put that into generation where it's going to say LC equals generation 2. The next time we find everybody who has a mother or father in generation 2. We put those people that we find in generation 3, and so on until the next time we search, there's nobody found. Even if there's 1,000,000 people in the hierarchy, if we only go 6 levels deep, we'll only have 7 hits to the database, the last one being an empty hit. So let me go ahead and create this function. And we'll execute it passing into person ID 1. And quickly scans down 5 generations of Holloways. So that's my favorite way of navigating a hierarchy and being able to turn data right into any other query using a multi-statement table-valued UDF as a data source inside of a query. So now that I've shown you how to navigate a hierarchy using a UDF, let me show you the recursive CTE, or the recursive common table expression. It's similar to the CTE we already saw, but it too will have an anchor and then a recursive call. So to walk through this, and this is the exact same logic as the UDF, but it's formed within a common table expression. So the common table expression begins with a with, saying with family tree, which is the name of the common table expression, and then here is going to be the 4 columns that are returned by the CTE, the common table expression, as, and then we define out a single select statement, similar to a subquery. And to make this a recursive CTE, we union between an anchor, which in this case is going to be selecting person ID information, and then you say union all with the recursive portion. And the join that connects each generation will be right here where we're actually connecting it to family tree. So here's the CTE, and we join to the CTE. I'm using an alias of FT to save some spaces. So the join is node, which is the next generation. Mother ID is equal to someone already in the current family tree generation, either as father or as mother. So when this is called, the anchor is executed once, and SQL Server will continue to execute the second one, unioning the results over and over again until nothing more is found. So as you can see, the logic is the same here between the recursive CTE and the user-defined function I showed you just a few moments ago. So let's execute this. One problem is, you see, we do have to hard code the value. I'll go ahead and put a 1 in here so it's the same. And when we execute this, we get the same result. Interestingly, if you do performance tests, the UDF is twice as fast as the CTE. So even though Microsoft really touted this recursive CTE as such a cool feature, I'm not a real big fan of it. But I included it here so your knowledge is complete and you can answer it on the Microsoft test.